On this video, we're going to look at electron configuration and electron arrangement. Let's start by looking at the energy of the electrons. The electrons of an atom have the same charge and mass, but different amount of energy. Electrons that have the lowest energy are found closest to the nucleus, where the attractive force of the positively charged nucleus is the greatest. The electrons that have higher energy are found further away from the nucleus. We know all this from Bohr's atomic model. If you remember Bohr's atomic model from the previous slides that I did with you, if you remember that figure with the nucleus at the center and the electron orbits around the nucleus. In this figure below, we are shown 4 different energy levels, with N1 being the lowest possible energy level. It is the ground state. Electron configuration is the way in which electrons are arranged around the atomic nucleus. According to Bohr, electrons move in particular energy levels around the nucleus, and the electrons can move between levels by accepting fixed amounts of energy during excitation to higher energy levels, or donating or losing energy when returning to a lower energy level. If you look again at our figure below, when going from the ground state, which is the first energy level, to an excited state, we gain energy. But when we move from the excited state back to the ground state, we lose energy. Electrons are very involved in chemical change during chemical reaction. We'll see this as we continue with our chemistry syllabus. Let's look at electron arrangement. We'll look at 3 diagrams showing the electron arrangement in 3 different atoms. The things to notice in these diagrams are that the first energy level can only hold 2 electrons. So if the first energy level has 2 electrons, it means that it is full. The second and third energy levels can each hold 8 electrons, and the elements all strive to fill the closest energy level that they can fill. Let's start looking at lithium. Lithium is in group 1 and has an atomic number of 3. Meaning that in a neutral atom, the number of electrons will also be 3. The first 2 electrons are found in the first energy level, and the third electron is found in the second energy level. So what happens here is that lithium prefers to fill the first energy level, because for it to fill the second energy level means gaining 7 electrons, because remember I said that the second energy level holds 8 electrons. So for lithium to be able to fill the second energy levels, it needs 7 more electrons. So lithium says, you know what, I'd rather lose the 1 electron on the second energy level and and stay on the first energy level because it's already filled. So let me just lose the 1 electron on my second energy level. That is why the charge for lithium is +1, because lithium prefers to lose the 1 electron on the second energy level. Fluorine has an atomic number of 9 and it is in group 7, meaning that a neutral atom will have 9 electrons. The first 2 electrons are found on the first energy level, and the 7 other electrons are found on the second energy level. Fluorine prefers to fill the second energy level because it says, why would I want to lose all my other 7 electrons to stay on the first energy level? For me to stay on the second energy level, let me just gain the 1 electron that I don't have than to lose all the other 7 electrons that I have. That is why the valency for fluorine is -1. So fluorine prefers to gain 1 electron so that it can stay filled on the second energy level. Neon is in group 8 and has an atomic number of 10, meaning that a neutral atom also has 10 electrons. The first 2 electrons are on the first energy level and the other 8 are on the second energy level. What do you think the valency for neon will be? It will be 0, because neon doesn't prefer to lose or gain any electrons because it's already filled. So it's like, why would I wanna lose or gain electrons, because I'm already filled on the second energy level, so I'm fine. I don't need to lose my 8 electrons to stay on the second energy level, and I don't need to gain another 8 electrons to stay on the third energy level. Now I hope you understand better why some atoms prefer to lose and some atoms prefer to gain electrons. Let's move on to orbitals. An orbital describes the area of greatest probability for finding an electron in the atom, and the theory was developed by Schrödinger. We have 4 types of orbitals: the s, p, d, and f orbitals, each with its own 3D shape. But for our syllabus in grade 10, we will stick to s and p orbitals. These orbitals should not be viewed as areas with fixed boundaries, but should be defined by the movement of electrons. Let's look at the orbitals now, the s and p orbitals. The s orbital has a spherical symmetric shape, and the nucleus is located at the center. We only have one s orbital per energy level, meaning that the first energy level has only one s orbital, the second energy level has only one s orbital, the third energy level has only one s orbital, etc. The size of the s orbital increases as the main energy level increases, meaning that one s orbital has the smallest s orbital, and the s orbital on the second energy level has a bigger s orbital compared to the first s orbital, etc. So as you go up the energy levels, your s orbital also increases in size. The p orbitals. Each p orbital consists of 2 teardrop-shaped halves, as you can see on the 3 diagrams above. And the first energy level doesn't have any p orbitals, so we have p orbitals starting from the second energy level upwards. And high levels each have 3 p orbitals per level. That is why you see the 3 shapes where the p orbitals aligned at right angles to each other in the space in the XYZ directions, as you can see in the 3 diagrams above. So the first one shows the p orbital in the y direction, the second one shows the p orbital in the x direction, the third one shows the p orbital on the z direction. That is it on this video. On the next video, we will look at the Aufbau principle.